Welcome to a video lesson on volume. In this lesson, we will be finding unknown dimensions. Let's take a look at our first example. And this example is in textbook page 55. The base of a cuboid measures 20 centimeters by 12 centimeters. As you see in this picture. The volume of the cuboid is 3,600 centimeters cubed. What is its height? I want you to notice that right now we're not trying to find the volume of this cuboid. In fact, we know the volume of this cuboid, and it seems like our work is done. Aha, wonderful. But the work that we're actually trying to do here is trying to find the height. So recall from the introductory video, or just your knowledge that you already have, that volume is equal to length times width times height. Okay, yeah, most of us know that. Great. We kind of needed that to do our last set of exercises. But if we know the length and we know the width, we could actually solve for the height. And we officially do that algebraically. But I'll just show you the formula for that. It's volume divided by length times width. And that means we could replace any of these letters with another one. So if we're solving for length, then the L would be there and H and W would be here. If we're solving for W, it'd be here and L and H would be here. But then notice that L times W, that's actually the area of the face. And we'll talk about that a little bit later. All right, so just to be clear, that L times W that's being multiplied down there is this 20 times 12, the bottom face or the base. So really any face or base of this entire cuboid could be called a face because you could rotate the cuboid. Well, let's actually do the problem. How about that? Enough chatting about it. Let's just do it. 3,600 divided by 20 times 12. And if we multiply 20 by 12, we could just do that long, multiplication by hand. We get 3,600 divided by 240. Now we basically have a division problem. And I'm thinking, well, all right, what can I do here to simplify this? So we could divide some zeros. That would be nice. But I want you to see that we could have divided a zero over here as well. So then we get 360 in the top in both cases, yes, 360 and 360. And then in this left part, we have 2 times 12 left, which is 24. Hey, that's that same number. Pretty cool. Now we have a little bit simpler problem, 360 divided by 24. And then we could just break this down and divide by numbers that we already know. I'm pretty sure both of these could be divisible by 3. So I'm going to find out how many times 3 goes into 360. Well, 3 goes into 3 once, 6 twice, and 0 0 times. So that result is 120. And then how many times does 3 go into 24? Well, let me think about my times tables. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. So that's 8. Now, again, there are plenty of ways to do this, and I could just keep having these numbers until I can't have them anymore. Half of 120 is 60, and half of 8 is 4, and h is equal to half of that is 30 over 2, and so the result is 15 centimeters. The only thing that is the same for all of these types of problems is that we're starting with something like this. We're dividing volume by 2 of the lengths. 2 of the measurements, I should say, because length is one of them. And then the rest of that is just whatever process that you're most comfortable with, dividing by 2 over and over and over. Or if it makes sense to multiply 20 by 12 first, that's great. Totally do that. If you want to divide out some factors first, then you could do that as well. Okay, that's the main thing. Let's take a look at a few other unique problems here. This one has to deal with the volume of a cube, such that it's 216 centimeters. And then we're going to find the area of one face of the cube. So what I'd like you to do is I'd like you to pause this video and try to solve this question on your own. Remember that this is a cube and all three sides are the same measure. And you could use that table that's in your notes from the previous lesson. And then when you come back, I'll have it solved. All right, so here it is. Basically, I drew the cube and I just labeled the fact that it's 216 centimeters cubed. Just put the numbers. And I'm trying to find the question marks. And really I want to try to find those lengths, widths, and heights so that I could find the area of one of the faces. So I think about, all right, is 216 a perfect cube? Well, I go through my numbers and I find out that I'm not quite there yet. And I think about 6 cubed, and I look at my table, that's 216. Otherwise I could have just, multiplied 6 by 6 by 6 to get 216. All right, now that means that each question mark is 6. So all three of those dimensions, those linear dimensions, are 6. So then the area of the face is equal to, well, just two of those. 6 times 6, which is 36 centimeters squared. Nice job if you got that. Let's do a few more. The next one is the fact that a volume of a box is 3,600 centimeters cubed, just like our first question. And it's telling us that our width is 15 centimeters, which was actually one of the measurements of our sides. And it says that its length is twice its width. Find its height. All right, go ahead and pause me, try to solve this on your own, and then come back and I'll solve it with you. Here we go. First thing is that the width is 15 centimeters. We're given that, which is right there. And then length is twice that, so 15 times 2 is 30. And we're just trying to find height. Now, the formula that we could use is simply that height is equal to volume divided by length times width. So that means that height equals, take that 3,600 like we've done before, and we divide it by 15 times 30. I'm going to divide out one of those zeros. And I think I'll divide out this 3 with this 36 and make it a 12. So that's actually 120 in the numerator. So I'll rewrite that. 120 divided by 15. I think I'll divide by, I don't know, 5 or 3. I think I'll divide by 3 on the top and the bottom. It's a little bit easier for my brain. I don't know. It's the morning right now for me. So that's 40, and that's 5, and then I could do a very pleasant measurement or division of 8. So 8 centimeters is the missing length. Great job if you got that. Okay, then we have just one last question, and it has two parts to it. We're going to find the unknown edge of each of these cuboids. So basically on the left here, we have two dimensions that are given to us along with a volume. And then we're given the area of this face over here, and we're given the volume. So your challenge is to try to work those questions, pause, and come back. Alrighty then, for part A, we're missing the height, and we're dividing 400 by 10 times 10. And that's 400 divided by 100. Now I just multiply that out because it's really simple. 10 times 10 is 100. And that missing length is 4 centimeters. The missing height, I call it a length because we could really just call things a length. We measure something, it's a length. Okay, if you haven't done the area of, if you haven't done part B yet, pause still and come back. Here we go. In this one, we're given that the volume is 768. So what can we do here? We could say that xy is equal to volume divided by area. Okay, cool. All right, I can do that. 768 divided by 96. Now, if you didn't work this already, I'd like you to now try to divide 768 by 96. Oh my goodness, here we go. 768 divided by 96. That seems a little bit too difficult, so what I'm doing now is I'm going to divide by 2 only. You know, I have a feeling I get to divide by 4, but I'm going to divide by 2, and I'm going to get that this is 3 with 1 left over, and then this is 16, so it's 8. That goes perfectly, so then there'd be 4. All right, so that means xy equals 384 divided by half of 96. Half of 96 is 48. You could have thought of that because half of 100 is 50. Now I think we could divide by 4. Let's try this out. 38 divided by 4 is 9 with 2 left over. 4 times 9 is 36. 38 divided by 2, or 4, is 9 with 2 left over. So 2, 24. So 4 into 24 is 6. 96. Oh, looks like 96 was indeed a factor. All right, so 48 divided by 4 is 12. And then hopefully you know that 12 times 8 is 96. If not, you could have just halved it and halved it and halved it until you got to the 8 centimeters. Ooh, getting kind of messy down there. Okay, well, I just wanted to point out that that formula that we used is volume divided by area, that the length of one measurement, could be length, width, or height, is volume divided by area. Another formula that we used was this one right here, volume divided by length times width is height. And then, of course, the normal volume equals length times width. Okay, hey, thanks so much for learning with me and finding unknown dimension.